Hi everyone, welcome to the ninth video in the series of algorithm animations. Today I will cover Kadanes Algorithm. I am Shreyaans Jain. Let's start. We have an array and we need to find a contiguous subarray with the largest sum. What is a contiguous subarray? A contiguous subarray is a continuous subarray in which we have not skipped any element from I index to j index. For example, if I have taken an subarray which is from ith index till jth index in the original array, so I have not skipped any index in that ith index to jth index. Okay, let's see. We have this array and we need to find the largest sum contiguous subarray. We will take sum and maximum sum, and using these two variables, we will try to derive the approach to find the maximum sum. Okay, so in starting, our sum is 0 and maximum sum is int minimum, so that we can store the maximum. We start with the first element. This is our pointer which will traverse the array. Okay, and so since we have taken -2, the sum will be 0 plus -2, so that will be -2. And our maximum sum will be -2 because initially it has int minimum as the maximum sum. So -2 is greater than int minimum. So we have stored -2 as the maximum sum. Now we have two options, either to include -2 in our maximum sub array or not. If we include -2, then it will decrease this maximum sum, because after -2, if we get either positive or negative, -2 will only decrease it. So it's better not to take -2. So we will reduce the sum to 0. We will start from the second element, that is -3, and we will update our sum. So our sum is -3, but -2 is greater than -3. So maximum sum will not be updated. Now the same question we have, should we take -3 in our subarray? This -3 will only decrease the maximum sum. Either the next element is positive or negative. So it's not beneficial for us to take -3. So we will avoid it. And we'll reduce the sum to 0. Start from the next element. Now we have 4. So our sum will be 4. And since 4 is greater than -2, so max sum will be 4. And now we will shift to the next position to try should we take next element in our subarray or not. Now comes a very important point. Should we take -1 or not? If we take -1, then the sum will be 3, and 3 is not greater than maximum sum, that is 4. So 4 will remain as it is. But the questions come is, should we take -1 in our subarray or not? Since the sum is 3, which is greater than 0, so we can try, like if I get some positive value after -1 and adding that to 3 gives us sum which is greater than 4, so we will have a subarray sum greater than 4. But if we don't take -1 and after that we got some big positive value, so we will lose a contribution of 3 there. Let me tell you again with an example. Suppose after -1 I get a big sum like 100, and here I have some 3. So if I take this sum 3, then it will become 103. There is a possibility. But if I don't take it, then the sum will only be 100. So I am losing a contribution of 3 there. And also I have stored that maximum sum 4, so we are not losing anything. So it's better to take it. Now taking -2 will reduce our sum to 1. Now again the same question, should we take -2 in our subarray or not? And here the same answer which I told in the previous step, like there are chances I get a big number like 100 after this. So adding 1 to it gives us 101. If we leave it, so we will only get 100. So there is some chance I can get 101, and that's how our greedy algorithm works. And we can get the maximum sum. So we will take it. Now we get a 1. So sum will be 2. But 2 is not greater than maximum. We will not update it and we will go further. Now the sum becomes 7. And since 7 is greater than 4, so we updated our maximum. See, here we got the benefit of taking -1 and -2 in our subarray. We got the additional 1 factor. Like if you take this subarray 4, -1 and -2, this overall gives us a contribution of 1. Now we will go further. Taking -3, our sum becomes 4, but 4 is not greater than 7, so we will avoid it. And since our maximum sum is 7, so we will return the answer 7. This was Kadane's algorithm. Let's see the pseudocode from the approach we discussed in the animation, and we will try to write some code to get you a more understanding. We have this Kadane Algo, which returns the maximum subarray sum, and we accept an array ARR. So as we discussed, we have a sum which is 0 in starting and maximum sum which is initialized with int minimum. And we will traverse like we traverse in the animation, our arrow traverse each element in the array. We find the sum and we then check two conditions there. What we check if sum is less than 0 or greater than 0. So what we did there was we checked if sum less than 0 or greater than 0. If sum is less than 0, then overall it will give a negative contribution to our further elements. That means if we have some positive element after that or some negative element after that, it will only worsen the situation. So we will then skip that element. And if that sum was greater than 0, so it will give a positive contribution to further element. Either it is positive or negative. So we have done the same thing. And if sum is less than 0, we will avoid that element. So we make sum equals to 0. And at last, we return the sum. Thanks for watching. Hope you will like it. Don't forget to hit like and subscribe to view more content like this.